Hello. Yeah, I'm Nick Lewis. I'm a software engineer at Puppet. I've been at Puppet for many, many years now. I initially worked on Puppet and Puppet Dashboard and Factor and all of the open source tools. And then I helped author PuppetDB a few years ago. I worked on that for 2 years and then moved to working on Puppet Enterprise on the Puppet Enterprise installer, rewriting that from 6,000 lines of bash to like 12,000 lines of Puppet code. And then about 2 years ago, I started working on Puppet application orchestration and the application modeling features that we released at PuppetConf last year. And today I'm going to talk about some extensions to the tooling underlying that for more general change management. But first, I want to talk about trains. Specifically, this high-speed train. I think trains are interesting as an analogy for, especially high-speed rail, as an analogy for what I'm talking about here, in that a lot of the effort and innovation that goes into making high-speed rail has very little to do with making trains go fast. That's kind of basic physics. More force, train goes faster. There's questions about where you get the force, but mostly it goes fast. The interesting parts are like, how do you keep it attached to the track? How does it not fly off when it goes around a tight corner? How do you make sure that the operator of the train can understand the track signals as they're flying past them at 180 miles an hour? Or however fast they go, quickly. And so a lot of it is actually about creating the right environment in which the train can safely go fast. And that's kind of the same sort of thing with configuration management, is that it's not about making change quickly, because that's relatively easy. It's about doing it in a way that you can continue to make change quickly because it's safe. And so I think this morning in the keynote, Luke and Jamie talked about situational awareness. And I kind of think of that as one of the core pieces of configuration management, is understanding the who, what, when, where, why, and how of the changes that you're making to your infrastructure, both while you're making them, in terms of whose job is it to make this change, when do they make that change, where does it happen, and after the fact, a month later, where did this come from? Why is it here? Who did that? How did that happen? And I think, so I want to talk about how we got to where we are, sort of building up from the basics. So I think the simplest form of config management is this: artisanal, handcrafted bits. That's, I need a change on a system, I need a package installed, so I SSH in and I do it. Like I said, it's easy to go fast. This is probably the quickest way to make a change to your infrastructure for a while. Once you get a bigger infrastructure, you're making more changes, you start to get bogged down in some of the trouble that you're causing yourself by not understanding exactly what's going on. It's also wildly unsafe. I think anyone would accept that just SSHing to your machines in a for loop and making changes is not a good way to operate if you want to understand what's going on, who made changes, when they happened, where they happened, why they happened. None of that is tracked. I mean, you can look at like who's logged in and maybe, but it's always root. And maybe run history and you can see what happened, but you don't know when or why. It does actually have, it makes some of the properties of while the change is happening pretty obvious, like who's responsible for making a change? Well, you are. What's the change? Whatever needs to be done. Where? Wherever you need it. But after the fact, you have no idea what's going on. It's impossible to keep track of all of the change that's happening, understand whether, I made a new web server. Does it have all of the things that I did over the course of 2 years to my old web servers? And the first improvement there is just to write bash, which, you can write some scripts, automate things. It gets a little bit repeatable. That's easy, right? This is a snippet of the new bash code for installing Puppet. It's great. You figure out what platform you're on, and then you run commands. This is all just to set up Puppet to then do more work. So obviously, that is not the easiest. But it does, it gets you some nice things. Well, I have code, so I can read the what, because it's in a script somewhere. And the sort of the who and the where and the when are kind of the same. It's ad hoc. It's I need to make a change, I'll run the script. So you write your script, and you run it in, let's see if my animations work. This will be real fun if not. Yes. You run it, in a for loop, and you make a change, and you get the changes. And that's great. But then, some time passes, and you want to understand what happened, and there's, again, no way to tell, because you've got the script somewhere that can tell you what would happen if you ran that script, but you don't know that it's been run. You don't know what it looked like at the time. And so, obvious next step, version control. So I push my code up to a Git repo. It's great, right? I file pull requests. I've got history of all the changes I made. I know who did it, when they pushed the code. I've got comments, and I can discuss why, whether this is a good change, and we understand why we did all of that. So this is great. I push it to Git. And then what happens? It's still the same problem, right? I pushed it to Git, but it's not clear how it gets from Git to wherever it needs to go. I don't know where it needs to go. Whose job is that? Is it my job as the person who wrote it, or is it your job as the person who committed it? Or is it, do we do it daily? Do we do it weekly? None of those questions are answered. And of course, you still have the same questions later that aren't answered of what actually happened. You know that, well, I pushed this change to Git, but that doesn't necessarily mean anything happened in the real world. So obviously, that's where Puppet comes in. That's the whole reason we're here. And Puppet solves this with a pretty easy model. It's, the who, what, when, where, why, and how, or at least the who and the when and the where, is every 30 minutes, Puppet will run, and it will get new version of code, and it will apply it. That's it. You don't need to know who's doing it. Puppet's taking care of itself. The where is everywhere. When is every half hour. And so the model here is I push to Git, and then I've got an agent that runs. It downloads a catalog, pushes to PuppetDB, change goes to the Puppet master. Puppet agent wakes up, checks in, makes a change, pushes to PuppetDB. It's great. I've got all of the data stored in PuppetDB, so I know where the changes happened, when they happened afterward. And again, with Git, I know who did it. It's a pretty straightforward thing, right? So to put it simply, nodes have a desired state, which is periodically updated and reinforced. That's the model of Puppet. We all know that, or at least if those of you who use Puppet know that. And I want to talk about a couple of words in that, though, which are periodically and. Nodes have a desired state, which is periodically updated and reinforced. So periodically causes some trouble. So suppose I push something to Git. When is that change actually going to make it out to nodes? I know that it's sometime in the next 30 minutes, but when exactly? Like, is it going to be 5 seconds from now? Is it going to be 28 minutes from now? It is going to be different on each of my nodes. So say I push out a change for my web servers. I have 10 web servers for my application. Some of them are going to get that change possibly right away, some of them not for 20 minutes. I might be serving different configurations based on which node you happen to hit. And the other thing is this updated and reinforced. So that means that every 30 minutes, every node gets a new catalog, whether you want it to or not. So if I push out something that affects my web servers, your web servers are going to get them as well if they're checking into the same Puppet master, whether you know it or not. And so we can look back at that same diagram again and see that what happened here is I push to my Git server, and then my third agent down there wakes up, gets a catalog, and doesn't actually make a change because the code hasn't yet made it to the Puppet master. So this is the periodically aspect of that. My agent may have just run when I pushed code, so now I have to wait 30 minutes for it to get that change, even though the first two have already got it. And so that brings us to direct change, which keeps ironically changing names. I think actually since I made this slide, it's now direct change control. But so this was you saw some of this in the keynote earlier. So Puppet Enterprise 2016.4 lays the groundwork for direct change, which at a high level is a much greater level of control over when and where and how change is applied across your infrastructure with Puppet. So it builds on the tech that we shipped last PuppetConf for application orchestration, which at a high level is two main pieces. That's language extensions to the Puppet language for describing and modeling multi-node applications. So you can describe the components that a node provides as part of an application, what applications that component is a part of, and the services that component provides to other services. And the other part of that is a command line tool for running Puppet in order based on those applications. So say run my database node and then my web apps, my app servers that depend on that database, and then run my load balancer. And this is a basic output from that. So here I'm running, at the top you can see -- application, that's a little cut off, RGBank dev. So that's run on the dev instance of my RGBank application. You see it's gonna run my database server, and then my web servers, and then my load balancer. This is great. It will run the database, and then it will tell me nothing changed on that server with the resource events, and it will give me a link to view the report in the Puppet Enterprise console where I can see everything that happened. And then after that, it will run the web servers in parallel because they don't have a dependency between each other. And it will do the same, tell me what happened, and then it will run on the load balancer. And then I get a summary at the end that tells me everything was good. And so this is really useful. You can run Puppet, and changes will be pushed out immediately, but you have to be using this application management construct because that's the only way to indicate to this what you want. You can tell it to run on all instances of an application, on all nodes in a particular instance of an application, or never mind, that's it. But that's not a problem, right? So all you have to do is reconceptualize your infrastructure as components of applications, write code to model all of that, and then you can run Puppet. Again, as long as you want to do it on a whole application. And so it turns out that not everyone is using those language features, but everyone who is using Puppet is running Puppet to make change. So we've added some new features in 2016.4 to make this a general tool that you can use to roll out change with Puppet, whether you're using application management features or not. In fact, we want this to be the way that you roll out change with Puppet. And so I'll talk about a couple of the features we've added there. The main two are that you can now specify a list of nodes to run or a PQL query. That's Puppet query language. There's also some changes under the hood to make it more amenable to running not in an application context. But so you can see the first example is I know that I want to run on these 3 nodes, so I just specify them. This is great. I really like this if I just want to run on a single node, because then I don't have to worry about whether I can SSH to it to run Puppet agent-t. I just Puppet job run with that node. The more interesting ones get into PQL queries. So the first query up there, which is the second example, is run on all of my Debian hosts, or OS family, so Debian, Ubuntu, those sorts of nodes. That would be useful if, say, I were making a change that affected my baseline configuration for all Debian hosts. Then I want to roll that out to just those nodes, and I want to do it as quickly as possible. I don't want to wait 30 minutes. The next one is anything with the HTTPD service. So those are my web servers. Run on anything with that service. And it's simple, but it's surprisingly powerful. I'll show some more complex examples. So this first one actually combines the previous two and then adds a bit more. This will select my Debian web servers, but only 3 of them. So this is great if you want to try out a change on some subset of your nodes. So say I want to run on 3 of my web servers, and then I'll do it without that limit to run on all of them. And as it is now, it's selected probably randomly, because I've just said 3. You can also order by name and choose the first 3 that way. Or you can combine this with the concurrency limits of a job to say something like run on 10 of my web servers, just 10 randomly chosen web servers, and do that 2 at a time. And then you can watch that job and say, oh, the first 2 succeeded, the next 2 succeeded, the next 2 failed. OK, I'm going to stop the job, which will stop running Puppet on the rest of the nodes, and I can go fix something. The second one, so these are the second and third are less complex structurally, but a little more interesting. So the second one there is run on nodes whose last Puppet run failed, which is useful on its own, but also especially useful if I combine it with another query to say, well, I just tried that job. It worked on 80% of the nodes. 20% failed because of this reason. So I've gone and I fixed that, and I want to retry it on just the nodes that failed. The last one uses code ID from the Puppet code manager features to say run on nodes that aren't on this specific version of code, which is especially useful if if all of your change is happening through this direct change. You might at some point forget to bring a node into the future with you. So you can just say, well, if you're not up to speed, run Puppet. And so because all of these jobs are stored in a database in the orchestrator, you end up with a complete record of every change that's been made to your infrastructure, who did it, when it happened. So this is who actually triggered the change, in addition to who wrote the code that did it, when it happened, where it ran, why it ran on those nodes. So you know it was nodes A, B, and C, and you also know that it was A, B, and C because it was your Debian nodes. And I don't know, you only have 3 Debian nodes. You know also what happened, what the result of that was. Oh, these nodes had changes, these nodes failed, these ones didn't. And that's all stored centrally. And because the Puppet Enterprise console, as again in the keynote demo, distinguishes between corrective changes and intentional changes, you can see easily whether the thing that you expected to happen on the node actually happened on the node. So say I made a change to this config file, and I ran Puppet on all my nodes. Did those nodes, and they have, say, 12 changes. Well, were those 12 changes related to the thing that I wanted to happen? Or were they other incidental things? And so I can see they were intentional changes, which mean that the thing I wanted to happen happened, whether or not other things also came along with that, because Puppet decided to correct some other resources that were wrong. And so that helps you sort of separate the signal from the noise so that you don't just get into this, well, there were changes, but I don't know what that means situation. And so, there we go. Putting that together, this, well, I'll just talk through this. So you push your code, and your code is picked up by your Puppet master. You then instruct the orchestrator to run. It instructs your agents to run. And they will all run, they'll make the change, they'll report to PuppetDB. Orchestrator will check PuppetDB, and it will indicate what happened to you. So that third agent wasn't run as part of the job. Also, I don't know why the clock is still spinning. Time keeps moving. That third agent ran on its own, on its 30-minute run interval, and also picked up the change. So that sort of goes back to I had periodically, and I had and. Should pick a more interesting word there. So that's again, the every 30-minute run will pick up changes if there are changes to be made, whether you want them to be made to that node or not. So my first 2 agents, I wanted to run Puppet on. The third one, I didn't want to have that update yet, but it got it anyway during its run. So for that, we have a feature that some of you may be familiar with, which is cached catalogs, which is when Puppet runs, it will save a copy of the catalog it retrieved locally. And then in the future, if it tries to get a catalog and it can't because it can't talk to the Puppet master, or there's a compilation error, it will use the cached copy of the previous catalog to reinforce the previous desired state, so that it at least will go make those corrective changes, even if it can't pick up the intentional changes. And that historically has had a couple of drawbacks, primarily related to files. So if you have a catalog that specifies file resources that are served by the Puppet master, those are referenced by name. And then when the agent runs, it will ask the Puppet master what the content of that file is supposed to be, and it will update itself if it's wrong. what can happen there is that you can push a new version of that file, and the catalog itself will not have been updated. So an example here is you want to update, you update your Puppet code to say, use a new version of this package, and also here's its corresponding config file. The cached catalog says use the old version of the package and download this file name. The agent will download the new version of the file, which doesn't work with the old package. And that's a little bit in the weeds. But the important thing there is we've added a feature called static catalogs, which causes those file resources to be looked up by content. So now when the agent runs, it will check the content of the file it has, it will check if the checksum in the catalog matches, and if it doesn't, then it will download the corresponding content from the Puppet server, not whatever the latest version is. And that, in addition to improving correctness of cached catalogs, also improves performance because the agent isn't constantly hitting the Puppet server for the unchanged content of a catalog every time it runs for every file. And so that has made cached catalogs a much more reasonable mode to operate in now. And so the idea here is that if your agents during their 30-minute runs, well, I guess I have another animation. If your agents during their 30-minute runs are configured to use their cached catalogs, they will not apply any changes. So you have this sort of, I think of it like a drum beat. Every 30 minutes, the agent checks its current desired state, and it makes sure that everything is OK. And it doesn't move forward. And then you can combine that with direct change to say that if I do want to make a change, I can select exactly where I want it to run, and it will do that as quickly as it possibly can, and only on the nodes that I told it to. So then you have much finer grained control over when and where your change gets applied. And so this looks very similar, where I push code, I run the orchestrator, which tells agent 1 to run, and then it tells agent 2 to run. It should be doing it in parallel, but you try doing that in Keynote. And then agent 3 will wake up, and it doesn't retrieve a catalog from the Puppet server. It instead uses its cached catalog. And you see, as I've indicated by the little document icon, it doesn't actually get that change, but it still reports to PuppetDB as normal. And so putting that together, that's separating the workflows of making change versus maintaining the previous desired state. So you have this baseline where the previously desired state is always continuously managed, and then changes occur deliberately and explicitly on the nodes that you choose. And then the results of those runs are delivered directly to you. You don't have to a common pattern for this today is to say use mcollective, where you can use mcollective to trigger Puppet runs. But then if you want to figure out what happened during those Puppet runs, you have to kind of go figure that out separately. And they're not, the context that I ran this change for a reason is sort of lost. All it knows is that all of these agents ran at the same time. It doesn't know why that happened. And so that's direct change. And again, we want this to be the way to make change with Puppet, such that if you want to roll out changes, you run Puppet on your nodes using Puppet job run. Right now, this supports in Puppet Enterprise 2016.4 up to 10,000 nodes on a single orchestrator instance, and we have plans to make scale out very easy here. And with the new client tools available on OS X and Windows, in addition to all of the Puppet Master platforms, which are a few Linuxes, you can run this directly from your laptop. You don't have to SSH somewhere just to run Puppet. Especially, you don't have to SSH to the node you want to run Puppet on to run Puppet, which makes it just that much easier to get your changes out. And so I want to talk a little bit about client tools. It's a single package that you can install on any node you want that provides some tooling out of the box for controlling your Puppet infrastructure. It has Puppet Job, which is the thing I've been talking about here for running jobs against sets of nodes. It also has a tool called Puppet Access for managing the, let me think how to say this, the role-based access control tokens in Puppet Enterprise. So you can do a Puppet Access login, give it your username and password. It will download a token that can then be used to authenticate with all of these services. So they're all controlled by Puppet Enterprise RBAC today. There's Puppet Code, which is used for pulling down the latest version of your Puppet code. And there is Puppet Query, which is used for executing Puppet queries using the PQL syntax, or I think also the original AST PuppetDB syntax, which I don't really know why you would choose to use that. But you can now use Puppet Query and see the results of that. So you can look at nodes, and you can do resources, facts, catalogs, and a couple of other things, reports. Which is really great if you want to just try out a query before you go use it in Puppet Job to see what nodes it's going to return. And I also want to talk about some of the future work that we have related to this in the short term. One of the big ones is open source tooling. So I said that we want this to be the way that you make change with Puppet, but the tooling is currently only available in Puppet Enterprise. So we are currently planning open source tooling that will provide this same workflow for all users. And we want that to be, we want it such that if you have a Puppet installation with a Puppet master, you get direct change control. We want it to be seamless and out of the box, not an additional thing that you have to set up if you want it. There are also some user interface improvements that we want to do here, in particular around the corrective change versus intentional change. That's not a distinction that is made everywhere. It's a thing that parts of the Puppet Enterprise console now will show you, but in fact, the Puppet Job tool itself won't. And that's a little important. And then this one's sort of incongruous in retrospect next to the other two, but today, if you do a Puppet Job run with 1,000 nodes, it will throttle the number of running agents based on a config setting such that it won't overwhelm your Puppet server. So that would be a classic problem. If you just do a Puppet run with 1,000 nodes, your Puppet server is going to fall down. But right now, it's a very coarse-grained restriction. It's just number of running agents, and we want to do this a little bit better around restricting specifically compilations. And again, it's a bit in the weeds, but I've done some math, and it looks like a 30-minute to 3-minute change, so it's worth mentioning. And then there's also some things that are a little bit further off. So those are near-term work. Ryan's in the back, and he can correct me if none of those are near-term work. And so one of them here is, I've just been calling it the laptop problem, but I put here asynchronous enforcement, which is, suppose you do a Puppet Job run to run Puppet on some set of nodes, but those nodes aren't currently available, like because they're someone's laptop and they've done something silly like gone home. They're going to miss that change. And if you've also adopted the cached catalog workflow, where unless you tell the agent to pick up a change, it won't pick up a change, then when they come back to work the next day, hopefully, their laptop doesn't know that it has a change waiting for it. And so there are some things we can do here where, in a similar vein to how Puppet is all about declared state and not operations, you could say that if I have told this node to run, I want it to be against this version of code, and then reconcile that. Another one is, so I just talked about how we want change to be direct and explicit, but there are actually cases where people rely on this implicit change. A common case here is code that will query LDAP for user accounts or users in a particular group and create user accounts as part of the catalog. And the process by which a user is added to LDAP might be completely detached from Puppet, which means that you can't expect the person who is onboarding a new employee to understand that they now need to run Puppet job to make that happen. And there kind of is a nice property that will get picked up on its own. And again, if all of your background runs are cached, then that doesn't happen. I would love to hear if you have more specific use cases about that, because we're talking about potential solutions. And the last one here is network devices, storage devices, all sorts of things that aren't traditional Puppet agents, in addition to non-root Puppet agents. Where today, in these cases, if you're using Puppet device or you're using the agent not via its standard service, you don't even get the 30-minute run. You have to come up with some interval by which to run Puppet yourself. And so I want to integrate these non-traditional agents into that same workflow so that they will run every 30 minutes for a cached catalog, and you will be able to directly apply change to them the same as you can with your existing agents. So that's all I've got. Oh. Somehow that. All right, well, I guess I had an animation in there. I have some time for questions, and I want to plug Ryan's talk on direct Puppet and application management for the Puppet platform, where he'll go into more detail about the components that make up this workflow and what our plans are for the FOSS tooling. And that is tomorrow at 1:30 p.m. in the Terrace Salon, which is somewhere is track 6. So questions?
So the 10,000 node limit that per orchestrator, is that the total number of nodes that can be in your environment or that can be affected in that run?
That's the number that can be connected to the message broker that is used to talk to the agents. And so beneath Orchestrator, there is a communication fabric that we call the Puppet Execution Protocol that has a server that your agents connect to via a WebSocket connection so that we can talk back to them. And it's basically just a limit from how many open connections we can have at once. And yeah, we have plans to make it easy to add instances of those, probably tied to your Puppet servers, so that because if you have 10,000 nodes, you probably aren't controlling them all with one Puppet master. And if you have multiple Puppet masters, you should be able to talk to your agents that way. So that's basically where that limit comes from. There's also some more work to be done there on the client tooling side, because I mentioned that it will run nodes in parallel, and it will say like started and finished, and it will tell you the events. That doesn't scale well from a user experience point of view. If you're running against 5,000 nodes, then you just go, oh, well, let me look at all of them as they go by. So there's some work to be done there too. It will work if you do that. It's just not the best result out of it.
Are the cached catalogs fingerprinted anyway so that somebody, I don't know, could potentially modify that cached catalog and then modify something about the server?
No, not currently. Currently, it's just a file on disk. Yeah, there are certainly improvements that could be made there.
So with all the SSL certs, it seems like it would be really easy to sign that and say, oh yes, this did come from a trusted master. Mm-hmm. It wasn't modified.
Yeah, that's a good idea. Up here. Oh.
Does the PQL use the PCP, PEP, or whatever the Puppet communication protocol, or does it use mcollective? Like the filtering, yeah.
Right. So it uses the Puppet execution protocol to tell the agents to run.
Okay.
Yes.
The second question is the last one. Is this integrated through the Jenkins? There was a demo about the pipeline plugin. Does that directly use some of these capabilities like the Puppet job and?
Ryan is nodding at me. Yeah. So this is all powered by a central service that has an API, so you can integrate it into your pipelines that way. That's something I should have touched on.
You showed the animation of 3 nodes running. What happens if someone commits code between node 1 and node 3 running?
That's a great question. So right now, the way the agent run happens is that it will just check in and get whatever the latest available code is. So if the code changes between the start of the job and the end of the job, you may get inconsistent results there. I mentioned that there's the problem of laptops disconnecting and coming back.
Exactly.
That's a similar sort of thing where really what this ought to do is specify a particular version that all of the nodes should get, even if new code appears. And that would have been good to mention in the future work. Yes.
But for this, I'm guessing you'd have to pre-compile catalogs and store them, multiple versions of catalogs, and then tell this node is for this catalog.
So at least in Puppet Enterprise, there's the file sync service, which will store. It effectively is a Git repo of all of your code, so it can pull up older versions of code. That's not a capability, like compiling against arbitrary versions of code isn't a capability that currently exists, but it's one that could be built using that functionality. And that has some extension points in open source so that you can hook it into your own Git repo. And I think Ryan will probably talk about that tomorrow. Yeah.
So we have a Jenkins job that gateways everything that goes into our prod repo. And once that happens, the deployment is completely automatic. We don't, so unless somebody needs a change to go out immediately, it's sort of eventual consistency. So if we switch to cache catalogs, if we want to continue to do hands-off eventual consistency as the default, and only use these directed runs for like on-demand, high-important stuff, how would we go about building that out? And we're using open source too, so like clearly this is not going to happen tomorrow.
Mm-hmm. So yeah, if you don't enable cached catalogs as the primary mode of operation for your agents, this will continue to work fine. Just their periodic runs will pick up change. So you won't be able to restrict nodes from getting a change, but you can still use the Puppet job tooling or the API from Jenkins or manually if you want a change out on specific nodes immediately.
So if we wanted to leave, so I like the idea of switching to cache catalogs. So I want to do that, but I still want to keep the automatic eventual consistency. Can I? Or does that force me into a workflow where if I want to push a change, I always have to have somebody push a button?
I'm not 100% sure I follow that.
I also might be horribly misunderstanding.
Yeah, they seem mutually exclusive. Yeah, those two concepts are mutually exclusive.
Okay. All right, yeah, so I wanted the performance benefits of cache catalogs and still get my eventual consistency.
So you can get the performance benefits of static catalogs,
Okay.
where the agent doesn't need to check in with the Puppet server for every file it manages. Static catalogs are on across the board for all catalogs. They just, the correctness benefits really only affect cache catalogs, except in race conditions.
Okay, thanks.
But that one potential thing there could be, say you have a nightly run that will pull in any changes that happened over the past day that weren't direct, so that during the day changes won't roll out automatically, and you get the performance benefits, but then you will still get them within a day. That's something you could possibly do. You could do that just by doing a Puppet job run on all of your nodes at the end of the day. Mm-hmm. Yeah, just run with no cache catalog also. Cron is good.
How does the orchestrator role relate to mcollective?
So Orchestrator is very specific today to running Puppet. And so mcollective is still around in Puppet Enterprise and still useful for inspecting the live state of systems and performing ad hoc tasks like package upgrades, et cetera. Orchestrator is specifically for running Puppet. Does that answer the question? Yeah, I think so. Okay.
So something I was thinking about when he was asking that question was, how about if the server side was able to answer a question like, oh, this catalog hasn't changed, just run with your cache catalog, such that it would also solve that, oh, my laptop just came back online thing, because it would come in and it would say, hey, I guess the way I would look at it is web servers will tend to respond with, oh no, this content hasn't changed, you're good. Maybe it could do something like that, I don't know.
Yeah, so that, I think the way I would phrase that is that running against a cached copy of the catalog and not recompiling the catalog is a separate thing from never talking to the Puppet server. So it could still ask, and the Puppet server would tell it, use your previous catalog. Yeah.
So arguably it would be less compute intensive to check in and say, hey, my code ID is this. Do I need to get a new catalog or not? I mean, I'm just thinking off the top of my head, but that seems like it would give you kind of the benefits of both ways. It wouldn't give you the ability to restrict, oh, yeah, you just use your cache catalog, don't get a new one. But using your code ID and coming in and checking in and saying, the Puppet server could just say, no, cached, go ahead, go.
Mm-hmm. That comment was, that would be fabulous for posterity. Yeah, so yeah, that's there's the direct aspect of this, and there's also the centrally managed aspect of this, which is...
The direct stuff is awesome. I really like, sorry. I was just saying, I really like the direct aspect because, God, almost every time I make a Hira change, I'm SSHing into a whole bunch of nodes and running Puppet agent-t. So that is awesome. I'm really looking forward to that. But the cached catalog thing is, that can make your Puppet, your compile master's requirement go way down.
Yeah, and I would say that there is also the aspect of this, which is there is now a service that understands what version of code any given agent should be on in terms of what you've told it to run. And I think that's a thing that we could take more advantage of to get to the point where, like you say, the agent could check in and find out that it doesn't need to get a new catalog. Yeah.
And maybe this is digging into the weeds a bit on this topic, but I'm just curious. We haven't necessarily talked about when the agent checks in, the first thing it does, right, is it runs factor and it checks all of its facts after it, in theory, does a plugin sync. But it does, so it figures out all of its facts and then it talks to the server. The conversation we're talking about, like, that's still happening before all this. So in theory, the biggest performance I would see, because personally right now I run a lot of antique Solaris boxes, don't tell anybody, is that a huge percentage of my agent runtimes is just running factor. Mm-hmm. If the agent can check in, check its code version first, and then decide whether or not it needs to run factor against its local, its local catalog versus getting a new one, that would actually, in my environment, that wouldn't just help my load on my master. It'd also help the load on my nodes as well, I would think.
Yeah. So a couple of things on that. Yeah. One is that Factor now has the ability to set a TTL for individual facts. Apparently, I learned this yesterday at the Contributor Summit. So you can tell it, don't recompute this extremely expensive fact that literally can't change. The other thing is that today, actually, one of the shortcomings of cached catalogs is that they don't report their facts to the server. I think they do still collect them, I'm not sure. So that we want them to still report their facts, but ideally with the TTL things, that would solve a lot of the runtime issues.
But also just factor free is ridiculous.
I'm running latest. It's
is it? Okay, you must have changed that.
That's old machines.
Okay. So that's about all the time. I would be happy to talk more about this at the party. Also, don't forget the party. It is again, the buses are right outside that door. Well, they're outside the building, but that way. That's it.